We've got a third example here for this miscellaneous type with the focus on the number of terms, and our example here, you'll notice the series is the same as the previous example. The only difference here is that we are summing to n terms where n is odd instead of even. Okay, so how do we do that? Well, we're going to approach it the same way, except with a little difference in the end, and we'll have a look at that difference. So first of all, we're going to let S sub n equal our series. Okay, and again, split it into two series, 1 plus 3 plus 5, and so on. But instead of to n over 2 terms, this first part, okay, is going to be to n plus 1 over 2 terms. And the second one, 2 squared plus 4 squared plus 6 squared, etc. That is to n minus 1 over 2 terms. Okay, and again, if we have a look at those, there, they need to add together to get the total number of terms that's given in the question. Okay, it's to n terms, and you'll find out that if you were to add n plus 1 over 2 and n minus 1 over 2, it would come to n. And the question is, why is it like this? Why is it n plus 1 over 2 and n minus 1 over 2? Well, that's what we're going to have a look at. So we're just going to, let's consider the case of 3 terms. What do we have? Okay, we'll have, for 3 terms in the original sequence, we have 1 plus 2 squared plus 3. Now, if we divide that into the 2 separate series, we have 1 plus 3 and 2 squared. Okay, they're the 2 separate series. Now you'll notice that this here is the n plus 1 terms over 2, because the number of terms, n, is 3, so that's 3 plus 1 over 2, which is 2 terms, which is what we have. We have 2 terms here. Okay, for this one here, okay, we can see that we've got, this is n minus 1 over 2 terms. There's 3 terms, okay, that's 3 minus 1 over 2, which is 3 minus 1 is 2 over 2, which is 1 term, which is what we've got. Okay, there's 1 term. Alright, so we could go again. We could consider 5 terms. Okay, what do the 5 terms have? We have 1 plus 2 squared plus, we're choosing 3 and 5 terms because it's odd. We're told here in the beginning that we've got the number of terms n is odd, and so that's what we're choosing. We're choosing an odd number of terms. 3 in the first case, 5 terms here, so it's 1 plus 2 squared plus 3 plus 4 squared plus 5. Okay, that's 5 terms. Okay, so the series we have is 1 plus 3 plus 5, and the other is 2 squared plus 4 squared. So this one we can see n plus 1 over 2, which is, how many is n? N is 5. Okay. So it's 5 plus 1 over 2, so that's 6 over 2 is 3 terms, which is what we've got. This one here is n minus 1 over 2, so that's 5 minus 1, which is 4 over 2, which is 2 terms, which is what we've got here. Okay, so what you need to do is, when it's odd, your first set of series starting here, starting at 1, whatever that series that starts there, that's going to be your n plus 1 over 2. The second series starting at the second term, then that's n minus 1 over 2. Okay, so that's for when you're summing to n terms when it's odd. Okay, what we're going to do, let's scroll down and continue. Okay, so moving on there, we're back to Sn, the sum to n terms, and we've got our 2 separate series. The first one, we've got this rule 2r minus 1. Remember that from the previous example, but it's from r equals 1 to n plus 1 over 2 terms, and then the second series from r equals 1 to n minus 1 over 2 for that series to r all squared. And then we can split that the same way as we did the previous one in the previous example. So you can see how we've split that into the 3 here now, and n plus 1 over 2 for both of these first 2 series from that original one, and then the last one there is 4 times sigma from 1 to n minus 1 over 2 of r squared. And we can continue then with this one as we did previously, working through, substituting in those results for r and r squared that are from our information sheet, and then simplifying, doing a lot of algebraic working, and then coming up with our final expression for the sum to n terms. Okay, once again, it's important to note that with our results that we get from our information sheet, those formulae for r and r squared, that we substitute the n plus 1 over 2 in place of the n for the first, and then with that last one here, okay, that we substitute the n minus 1 over 2 wherever you see the n in that r squared formula. Okay, that's really important to remember and not to skip out on that. Okay, so then we need to work through that and simplify it. We can see here that those 2's are going to cancel, and the 4 and 6 again is going to reduce down to 2 over 3, and then we can work through and simplify that. So we've worked through these last few lines. Just again, just make sure you're able to see where these lines, how they've worked out, and you can see that there's no specification in the question as to whether it needs to be factorised or not, so either of these last 2 lines would be okay as an answer. Okay.